Alright, happy new month, everyone. For the sake of the recording, as always, GM, I am Nos, I am one of the co founders of the AI Guild, and congratulations, you made it through week one of the. You made it through week one of the AI development track of the Saks AI Guild Bootcamp. I am happy to welcome you into week two, where we would be building out and fleshing out our applications and solutions and turning them into Web3 native solutions. As always, this AI bootcamp wouldn't be possible without our very good friends and our very good friends and co-partners of this bootcamp being Biflow. So, with that out of the way, let's just do a soft recap of what we have done in the past week. So, uh, last week we worked with prototyping with lovable.dev and extending those prototypes with what we like to call agentic development environments like anti-gravity, cursor, or the mix of Visual Studio Code and Copilot to flesh out these applications. Now, while prototypes are good, the main goal of this bootcamp is to turn idea men into product makers, right? And while we've done prototyping and it's very good for the iteration of ideas, iterating ideas and uh, receiving valuable feedback fast, right? We would be moving on to scaling actual applications, businesses, and solutions with these AI workflows and tools. By leveraging these tools, we can enhance our prototypes and streamline workflows, paving the way for robust, scalable applications in our upcoming sessions. So, congratulations, you've gone from a prototyper. Now we are going to work on building actual products. Last week, I told y'all to think about MVPs, think about problems, right? This week, there are no assignments. There are no assignments this week. Your assignment this week is to, well, like I said, there's no assignment, but there is a bounty this week. The bounty this week, and that's the bounty that's going to close out the bootcamp, is to build, launch, and get valuable feedback from whatever application that you will build over the course of this week. And the bounty would end, I believe, on the 10th of this month. So the clock starts now, and you have 10 days, and we have 7 days to teach. So it is expected that whatever you get here, you apply, you try, you test, you reiterate, you discuss within yourselves, and you do enough research to build out. Again, you can lead a horse to water, but you can't make it drink. We are on the move to turn you guys from idea men to problem solvers to product makers, and we can only do that when and if you can do research. Okay, so what we're going to be doing this week is pretty simple. We're just going to be extending on our prototypes. So today's task, really, it's not an assignment. With that idea that you had in mind over the weekend, work on a prototype with either Lovable or Google AI Studio. Then clone that prototype and implement core features, or clone that prototype into your ADE, be it Cursor, Visual Studio Code, or whatever, and then implement the workflows that we would be handling over the course of 1 week. So that's your task for today. That's your only task. So what are we doing this week? Okay, this week we would be covering, or what are we doing today? Today is just an overview. We'll be covering the foundations of agentic app development, right? Uh, we'll be discussing the essential tools and concepts that relate to agentic application or agentic solution processes. So let's break those down bit by bit, the overview of this week. So we're going to be taking key learning targets, right? Key learning targets. We're going to be working with AI agents. We're going to be working with MCP servers, and we're going to be working with backend APIs. Uh, I, I think I should share the lecture notes for this so you guys can be more aware. Uh, Over the course of this week, we would be working on one, fleshing out our own custom knowledge base, two, building out our own custom MCP server, three, building out custom APIs and configuring API points to our applications, and four, automating this entire process with AI agents and handling an agentic workflow. So what do I mean by an agentic workflow? An agentic workflow is a process workflow, a system design workflow that has different agents do different things. So you could have an agent for UI, you would have an agent for backend logic, you could have an agent for state management, you can have an agent for this and an agent for that, right? So our key learning targets this week is automating tasks using AI agents, connecting and building out our MCP servers so we could use them to supercharge production, and backend APIs, building robust infrastructure for application functionality. So before anything, if you don't know uh, what an API is, an API basically stands for an application programmable interface, right? Uh, Basically what it is it's a part of a website, or it's a part of an application that you can pull information from, right? So let's call it a cheat sheet. Let's call it a cheat sheet for your favorite book, right? You don't want to go back to the library to get your favorite book to read, but you have a cheat sheet for it. So that's basically what an API is, the easiest way that I can uh, define it. So we'll be working on these three: AI agents, configuring, and working with MCP servers. We'll be working with the MCP server from stacks and backend APIs. So this week's goal is to build decentralized AI-driven applications. Uh, our focus this week is on leveraging agentic development environments like Cursor or Anti-Gravity to create intelligent, decentralized applications using AI technology. So, what does this mean? It means that we are going to use agentic workflows to build out Web3 native solutions. So, if you've been wanting to get yourself into the market as a developer, right? Uh, as a developer, and you're finding it a little bit cumbersome to either pick up a language or to get your foot in the door, this should be able to get your foot in the door. Building out something that is functional, that has weight to it, that is scalable, opens you up to not only investors but to other developers that are willing to aid push your craft. So this week's goal is pretty simple, and this week's goal is going to be highly incentivized. Like I mentioned before, there is a bounty up: first prize 100, second prize 50. uh so that's this week's goal: build decentralized AI driven applications. Now, I'm not going to tell you to go and build an entire liquidity pool. I'm not going to tell you to build an automated trading assistant. I'm telling you to build out a solution that fits you. A solution that fits you, that fits a problem point that you have, that fits an onboarding issue that you have. Think of yourself as someone lost in Web3 and find a way to introduce that person a solution that would not have the Web3 feel to it, that would not make it cumbersome. That is the goal for today. That's the goal for this week, rather. So, let's introduce some core concepts. Let's understand agentic development, or the Agentic Development Environment Framework. The ADE framework utilizes AI agents to efficiently manage development workflows, enhancing productivity and scalability. Like I said in the beginning of this course, we are entering a new phase of software engineering where it would be your main goal as a software engineer to handle system design. System design is one of the first principles of software engineering. Anyone that studies computer science would know that. So you would be focusing more on designing systems. And then the entire coding process, the CI/CD, that's the continuous integration and continuous development process, would be entirely automated. So your job is to build systems that work and that are scalable. After that, you can employ AI agents to do specific tasks for that system. And that is the entire framework of the ADE. Employing AI agents, Gemini, Claude, ChatGPT, Perplexity, Grok, to efficiently manage development workflows, to automate development workflows. So let's define a clear difference between prototyping and production, because a lot of prototypes could go out, but none of them could be scalable, right? If you've taken your time to go through Twitter, you would be seeing a bunch of what I would like to call them is AI jargon. By AI jargon, I mean AI applications that are not scalable, that cannot be put to scale, right? What differentiates you from them is they launched a prototype that does 10k MMR and it's selling to a marketplace of people that do not know anything about applications or do not know anything about sustainable applications. The difference between them and you is you are working as a system designer and an architect that knows how to scale applications, how to scale solutions. So while they are launching a prototype that is able to do 10k MMR, you're going to launch an entire system that is going to be continuously in use for 5, 10, 15 years, and it's going to continuously bring you money, right? So quick prototyping is going to allow you to get those quick little functional models, testing ideas, and it's going to enable you to get back user feedback before committing actual resources, before committing actual time, money, development hours to this. But scalable systems are going to require you to grow not only as a quote-unquote prompt engineer, it's going to force you to grow as a systems architect and a systems designer. So that is the main difference. While prototypes are going to be very, very good to flesh out an idea, to test it out with a couple people, once you're done with the prototyping phase, you're getting into building scalable systems. And building these scalable systems would put you in a position where an ADE or an ADE framework would be substantially helpful, right? So what we're going to be doing this week is marching ourselves on the path of building scalable systems. Importance of TDD for reliable and maintainable code. So what is TDD? TDD is test-driven development. So what does this mean? We're getting to a point in AI, right, where as a junior developer, AI AI is basically going to replace a bunch of junior developers. We know that, right? It's going to replace a bunch of junior developers. If you're still working on applications and you need someone to write functional tests for you, or you're not familiar with writing functional tests, or you do not understand where an application is doomed to fail, or if you do not understand pitfalls and bottlenecks, AI would replace you, because what you're doing is you're just writing code, and AI can do that already efficiently. What separates you from someone that AI can replace or pseudo replace is the ability to understand pitfalls, and most importantly, write tests for those pitfalls. So a test is basically a safety net, right? It's basically a tightrope and a safety net. So a test is going to check if a particular section of your code is working, right? It basically tests if your code is working as it's supposed to, if it's giving the right outputs, if it's connecting to the right server endpoints, if it's doing the right thing. That's what testing is, right? Testing is supposed to curb bottlenecks. What is a bottleneck? A bottleneck is a pitfall. What is a pitfall? A pitfall is a problem. It's supposed to curb problems in your codes earlier, so you don't spend time, effort, and energy fixing these issues, right? There are different types of testing. There's unit testing that breaks down code to, you're testing each and every single component. There's integration testing that checks how code or how blocks of code interact with each other, whether they interact with each other properly, right? Your job as a system designer, as a system architect, is to understand or to map out where exactly you would get tests early. So before the code is written, you already have an idea of where these tests are coming from. Now, in the course of this week, we would be working with what I like to call an iterative process, where you would be learning about errors and how to fix them. We did this in the last class, right? Where we saw Gemini make a mistake and it kept us here for like an hour and 30 minutes. Now, we knew what the issue was. Right? We knew what the issue was. But we went through the iterative process of trying to find out, or trying to put ourselves in the shoes of a junior developer, right? That does not know what is what. So he duplicated code 1, and then when the screen went blank, it just commented the entire index page, right? So imagine yourself as someone who has no idea of testing, right? Who has no idea to check whether things are functioning properly. You're going to be in a recursive process of AI making mistake after mistake after mistake after mistake, when the one issue you could solve would be a direct file, right? Over the course of this, we'll be looking at reading into error messages, even though reading into error messages and using AI research tools to kind of pinpoint problems. Pinpointing these problems would work for next time, because of course when you're doing test-driven development, you'd need to understand and notice tests. So the more tests you see, the better you are at fixing them. Okay. So what tools are we going to be working with? We're going to be working with 4.5. Again, a very wonderful stack for anyone that wants to start building with agentic development workflows. We're going to be working with Claude 4.5, Gemini 3.0 for the front end, and then we're going to be using Google AI Studio for prototyping. We're not using Lovable anymore. So we're going to go straight from Gemini to Gemini. So we're going to go straight from Gemini prototyping to Gemini system development. Now let me show you why this is going to be very fun. me a second. Let me show you why this is going to be very, very fun. Because with the new workflows, oh, I should not be opening this here. What the hell?